Students online, can you hear me? Hello, students, can you hear me? Okay. Fine. Today, inshallah, we are starting with our meeting number 6. It is on algorithms. We are going to discuss here, inshallah, in detail about algorithms. Okay. We are done with meeting number 5 in our last week, that is on loopings, and we saw some programming on it, right, using loops. So today we are going to start with algorithms. Is there anything left from part 5? I mean meeting number 5? Do you remember that? Is there anything left from meeting number 5? So we completed, yeah. Sorting is meeting number 6. Meeting number 5, I think there is no sorting. Is it like that? We finished it, huh? Okay, today inshallah we'll talk about algorithms, that is in our meeting number 6. Now it is not uncommon to read articles with title like Google algorithm for ranking web pages or Facebook algorithm for creating news stories. We all see some or the other algorithms in our life. Okay. So our civilization is increasingly reliant on algorithms. Therefore, it is worth learning more about algorithms. What are their strengths and weaknesses? You have learned that an algorithm may describe how a problem can be solved, is what algorithm. But we are going to go in more details about the algorithm. What we have learned is an algorithm is a step-by-step guide completing a particular task. This is what algorithm is. Algorithm is a step-by-step task or a step-by-step procedure to solve a particular problem or completing a task. Many of our everyday activities follow some algorithms. For example, you wake up, you brush your teeth. So brushing your teeth, you follow some algorithm, some steps like turn on tap, wet toothbrush, fill glass with water, turn off tap, apply toothpaste on brush, brush teeth, spit out toothpaste, rinse mouth from glass, empty the glass. These are the steps, when you early morning you make brush, you brush your teeth, right? So in everyday life, we are following some or the other algorithm. We are under some or the other algorithm. For example, algorithm to prepare something for a recipe. Okay, you know better. Like when you want to make something, you want to make a coffee. What you will do? What is the procedure? You want to wear the clothes. What you will do? What is the procedure? You want to do something, you know what is the procedure, right? So we all know that some or the other, we all know that we are doing some procedure, some steps, okay, to complete it, right? So that's becomes an algorithm. That's become an algorithm. Now, the fundamentals of algorithm is that a well-written algorithm for a program can be implemented in a variety of programming languages. So, if you have a algorithm well written, and if you have a good algorithm, this algorithm can be implemented in any programming language to make a program or to make a software. Okay. First thing is that you write an algorithm for any problem. Then that algorithm you can write by using some programming language, like by using Python or by using C programming or by using OU build. Okay, any other programming language, Java or C Sharp, ASP.NET, any programming language you can use to implement that algorithm. But provided that the algorithm is well written, a good algorithm. The implementation of algorithm in different languages, of course, all look different, but they share the same fundamental features described in the algorithm. Different languages like we have PHP, we have Python, we have C Sharp, we have ASP.NET, we have C programming, C++, different programming languages have. But the algorithm is same for all. Algorithm is one. We describe what are the features, how to run the things, what are the steps. That steps or that algorithm you are going to implement by using some language. So understanding these fundamental algorithm features can help you more readily understand programs even in language that you are new to. So algorithm is a step-by-step instructions to complete a particular task. Similarities between everyday algorithm and those used for programs both have a set of instructions. Okay, both complete in a finite amount of time. A finite amount of time, it means every algorithm will start and will end, will stop, will end, must end. So algorithm has a set of instructions. Like for example, you want to make a cup of coffee. How the cup of coffee is made? You take some hot water, you take some milk, you take some coffee, you take some sugar, you put the hot water in a glass, add some sugar to it, add some coffee to it, add some milk to it. Okay, shake it well, you'll get a coffee ready. Okay, these are the instructions. So you have a set of instructions, like 5 to 10 instructions. Fine, and these instructions will complete in a time. For example, it will take 2 minutes, it will take 10 minutes, but there is a stop. You shake well, your coffee is ready. So there you stop. So you have the step one, then step two, step three, step four. Finally, you're gonna stop it, finish it. So that's what it means. Both the algorithms and the programs, the computer programs, what we write, will complete in a finite amount of time. We'll have the instruction or finite set of instructions. Differences between algorithm and those of programs is that every algorithms are imprecise and might omit an instruction relying on human previous experience or general knowledge. For example, a recipe might bake for 45 minutes or 180-degree without giving explicit instruction to turn on oven and turn off oven. Right? What we said in making cup of coffee, for example, we said hot water. So we omit one thing. What? Boil the water. Boiling of water is omitted from our example. Fine. This is because based on our knowledge that okay, to make a coffee we need a hot water. So no need to say like okay, boil the water, take the water, boil the water. If you go in more detail, collect the water, boil the water, then add the water in a glass. These things, okay. But the programs in program when you write a program, you have to go every detail. In program, you have to go every detail, every function. Algorithm for program must be precise, self-contained. They must contain all instructions required to solve the problem, and those instructions must be unambiguous because computer cannot understand if there is any ambiguity. This means that all the instructions in the algorithm that you want to implement it, or you want to program it, must be very clear, must be very clear, and there should be an instruction in the programming language for every instruction of algorithm. Okay, so algorithm, for example, add two numbers. So we say that input number 1, then input number 2, then add number 1 and number 2, and then print number 2. So what happens here is you have to take number 1, what is input in programming language? What is input in programming language? How do we add numbers in programming language? How do we print number in programming language? So there should be a equivalent statement, equivalent instruction in programming language for every instruction of the algorithm. Then you can easily implement the algorithm into program. You can easily convert that algorithm into program. So implementing their own algorithms, a programmer might clarify the ambiguity and fill the missing steps, thereby will arrive into a working program. One advantage of algorithm is that once an algorithm is written down, it can often be reused over and over by the people who want to solve the same problem in different programming language. It means that you can reuse the algorithm. Once you write an algorithm, you can reuse the algorithm. There is nothing that you cannot reuse the algorithm. Any problem you write an algorithm, this algorithm can be used by any person who want to solve the same problem. For example, I write an algorithm to make coffee. So any person want to make the coffee can use my algorithm, write a program to make a coffee. It is reusability. Okay, regardless of different programming language. I am using here, for example, C sharp to write a program to make a coffee. Then my friend says like, okay, I want to also write a program to make a cup of coffee. Can I use your algorithm? I say, okay, you can use my algorithm. He will take my algorithm, he'll see the algorithm. The algorithm is correct, perfect. Okay, and then he can write the program by using another language. For example, by using Java. He can write a program to make a cup of coffee by using the same algorithm. That means that we can, once we write an algorithm, this can be reused by many other people or someone else who want to solve the same problem. Okay, so if you want to define now algorithm more precisely, what is the definition here is that algorithm can be defined as a set of unambiguous it means clear, there is no ambiguity, there is no difficulty in understanding the steps. The steps are clear, self-contained steps, step-by-step instructions guaranteed to complete a particular task in a finite amount of time. So this is more precise definition for algorithm. This is more precise definition for algorithm. Fine. Is it clear to all? Students online, is it clear? How about the other students? Is it clear? So this is the definition for algorithm. If it is asked you in the exam, write what is algorithm or define algorithm, you need to write this definition. You need to write this definition. It is a set of unambiguous, self-contained step-by-step instructions guaranteed to complete a particular task in a finite amount of time. Okay, this is more precise definition. Refinement, ambiguities. How to remove the ambiguities? Ambiguity is a real problem for algorithm designed for programs. Ambiguity, it means things are not clear, steps are not clear, steps has some ambiguity or some difficulty in understanding, in converting into programs. Okay, that is called ambiguity. So ambiguity is a real problem for algorithm designers. Okay. Ambiguity can be overcome by breaking the instruction into smaller steps to clarify the order of individual action. So we can break the instructions into smaller instructions to clear the ambiguity. Okay. This process is called refinement or decomposition. That is, breaking the instructions to make it more clear. We call that as a refinement of instructions or decomposition. For example, let's start with the instruction deduct rounded discount amount from total price. Deduct rounded discount amount from total price. Now we need to understand this is one step in algorithm and one instruction in algorithm. Is this instruction is clear or it has an ambiguity? Students online. Is this instruction deduct rounded discount from total price is clear or it is not clear? If it is clear, how come it is clear? Like, if you don't know what is the discount, how come it is clear that if you don't know what is the discount, how come it is clear, you don't know what is rounded discount, right? And deduct, my statement is deduct rounded discount amount from total price. This statement has an ambiguity. Ambiguity, it means the statement is not clear. Why not clear? We don't know what is rounded discount. What is the discount? How much is the discount? We don't know. Okay. Then we might refine it. We need to refine it. We need to rewrite this in more clear steps, like calculate discount as 20% of total. So here we are calculating the discount. So this is what is the discount now? It is 20% of the total. If the total price is 100, 20%, 20 is the discount. Round the discount and you make a round figure of the discount. Reduce the price by discount. Reduce the total price by discount. So you see that this one step is refined into three steps, making it more clear what it mean here and what you can implement in the programming language. This is called refinement. This process is called refinement. Okay. So did you get what is refinement? Students online, did you get what is refinement? Okay. The next is fundamental features. Computer programs vary in purpose and complexity as in the language they written in. For example, Google search engine, camera face detection software, artificial flight control system, income tax calculator. Okay. They have the different purposes and has different uh, complexity. Rian says it's rewrite algorithm in a clear way. Yeah, that's what the refinement is. In refinement, we are rewriting the algorithm or rewriting the steps of the algorithm which are ambiguous or which are not clear. Okay, that is a refinement. So it's not complete algorithm, it's only those statements which are not clear. We are going to rewrite them. Okay, clear, Rian? Okay. Now, computer programs vary in purpose and complexity, and every program of the computer has different purpose and has different complexity. For example, if you talk about Google search engine, why we use this Google search engine? Students online, why we use Google search engine? Yes, look for something or search something to search something or look for something. That's why we use this Google search engine. Okay, so it has a different purpose. It has a different complexity in searching the items what we are looking in. Search about new things. That's good. Camera face detection software. They detect the face of a human beings or face. So now it is different. It has different purpose. It has different complexity. So every computer program has a different complexity and different purpose. There are many tasks these programs perform based on algorithms, that is, they follow the precise, finite, step-by-step instructions. The algorithm for these and all other computer programs are built around four simple ideas. Any algorithm for any program is built on four simple ideas. And these four simple ideas are input output, sequence of instructions, repetition, and selection. We talk about sequence instruction, we have discussed repetition, we have discussed selection in our previous classes. Okay, input outputs, we know the input outputs. So any algorithm that to implement that as a program is based on these four simple ideas. By combining these four simple ideas, we can create an algorithm. We can create an algorithm. Input and output, it is possible to imagine someone writing an algorithm that takes no external input and that's always produce the same output. But as a rule, an algorithm that always produces the same output will be little of use. We want algorithm to be able to start with different data inputs and produce different output based on the different input. So we want algorithms that takes different input and give us different output. It is not like the algorithm gives us takes same input every time and give you same output every time. That algorithms will not lost in use. Okay, that will be discarded very soon because we'll come to know that what is the input and what is the output. Fine. So algorithm, we want an algorithm that takes different input, different data, different input at different time and produce different output based on different input. Produce different output based on different input. So for example, if you want to write a algorithm to if you want to write an algorithm to make a cup of coffee, fine. So coffee can be of different type. It can be cappuccino, it can be or French coffee, it can be any other coffee. Coffee with milk, coffee without milk, coffee with sugar, coffee without sugar. Okay, different inputs will give you different outputs. Fine. If you don't add sugar in the coffee, this is a sugarless coffee. If you add sugar in the coffee, this is coffee with sugar. Fine. So the algorithm what we write, okay, should be able to start with the different inputs, different data, different inputs, and should be able to produce different output based on different inputs. This enable algorithm to be more general purpose problem solving tool, providing different solutions in different situations. It means different inputs in different time. For example, if you look into this algorithm, what is this algorithm doing? Yes, students, what is this algorithm doing? Or what is this algorithm about? Output the average of output the average of what? Of two numbers. So this algorithm is to output the average of two numbers. Okay. So if in this algorithm, if we give two numbers, different numbers at different time, you get different output, right? If you write this algorithm in OU build, says ask the user enter first number 1, enter the first number, then enter the second number, and then we calculate the mean and we say mean is 2 or the average is mean. Okay, now different this algorithm, if you put this, it will ask you different inputs and give you different outputs. So we consider this as a good algorithm. Okay, that it takes different inputs and give us different outputs. Give us different outputs. So if you talk about this one, so let's say like okay, ask the user to enter first number, first number. Okay, and let's say we make a variable as n1 as number 1 and n2 as number 2. Okay, and we set n1 to answer, sorry, n1 to answer. Then again we ask this enter second number and we set n2 to answer, and then we create a variable called mean or average. Okay, and we say set mean is equal to what? n1 plus n2 divided by 2. So it says n1 plus n1 plus n2, sorry, divided by 2. Set this as mean. Okay, and finally say that mean is or the average is mean. And say this. Okay, so when I click the flag button, enter the first number and say 12, enter the second number 12, mean is or the average is 12. Next time I enter 2, 3, average is 2.5. So you see that different time I enter different values, I get the different result. That's what here it is. This is considered as more general algorithm. In other programming, like in Python programming, it is the code here. Input enter first number, input enter second number, mean you calculate mean as float of number 1 plus float of number 2 divided by 2 and print the mean. Okay, this is in Python programming. Okay, so not all input data for an algorithm comes from the user. Some data of an algorithm might be come from the environment or from the program itself. For example, consider the following simple algorithm as tell us what last year was. Now tell us what last year was. If you want to write this algorithm, simply say that get this year, subtract -1, display last year. No, get this year is coming from the system. It's not from the user. It's coming from the system. So some data user will enter. Sometimes some data is taken from the system. Sometimes it happens both. Sometimes it happens both. Okay. So that is about the input and outputs in algorithm. So every algorithm, as I said, follows these 4 steps. The idea of these 4 steps. There is a question, Abdul Majid Al-Karmi says, exam outcome like the subject today. So in the exam, there will be questions on algorithm, write an algorithm. In the exam, there will be question on what are the 4 steps for algorithm, that for this 4 steps. Or they'll give some algorithm and ask you to write how you build for it. Or they'll give some question and ask you to write algorithm on it. Okay. This is all about writing some good algorithms that can be easily converted into programs. Okay, here is a sequence, repetition, and selection. The next 3 parts. First part, what we said is input and output. So we discuss input and output. Inputs, the algorithm basically must take the different input at different time and give us different outputs based on the different input. Any algorithm that does not take an input and produce every time the same output is not a good algorithm and will not be used for a long time. Okay, the inputs can be from the user and sometimes can be from the system. Okay. That's about the input and output. The next part here is sequence, then repetition, and then selection. We talk about these 3 parts in our previous lectures. Repetition, what does it mean? Students online, repetition means what? Repeat. What to repeat? Yeah. What to repeat? Repeat until. Repeat forever. Repeat number of times. Repeat. So what to repeat? Repeat a set of instructions, okay, on particular number of times. It can be number of times, it can be forever, it can be until some condition is satisfied. Until so repeat until some condition is satisfied. For example, suppose a cola merchant is giving loyalty points for their customer according to the following algorithm. It says repeat 6 times, input box price, add box price to the total. If the price is greater than 5,000 euro, then calculate loyalty points as 5% of the total price, rounded to the nearest whole number. Tell the user loyalty points earned, else tell the user no loyalty points earned. The above instructions are followed in sequential order from top to bottom, except where an instruction involves repetition or selection. Now there is no sequential here. There is a repetition. Repeat 6 times, right? So repeat 6 times. Say this. Repeat these instructions, which is under repeat statement. Input box price, add box price to the total price. Input box price, add box price to the total price. Input box price, add box price to the total price. 6 times it goes. It repeats this behavior. Then, if the total price is greater than 500, calculate the loyalty point as 5%, round it to the nearest whole, and inform the customer that loyalty points are earned. Else, tell the user no loyalty points. So, this is a selection. This is repetition, and here we have a selection. Here we have a selection. Sequence, we have this one. Input box price, add box price. Calculate loyalty points, inform the user or tell the user. This is in sequence, one after the other. Okay. The algorithm repetition starts with repeat 6 times. This instructs the algorithm to repeatedly iterate through the intended sequence of actions. These two actions in sequence that are repeated for 6 times in the same order. Get the box price, add the box price to the total price. Okay. So we say that, for example, repeat 6 times, enter the box price, set the box price, and total add total price to box price. Change to total price by box price. It means add the box price to the total price. Fine. This is in OU build. Similarly, we can write this in Python programming language. Total price is equal to 0 for items in range 6. It means this is repeat 6 times. For item in range 6 means repeat 6 times. Box price input, enter the box price. Total price is total price plus the box price. No sound? Are you sure? Other students, can you hear me? Students online, can you hear me? Hanna, I think it's a problem from your side. Hanna, can you check from your side? Okay, that's good. Okay, so here, there is a repeat statement. So under the repeat, there is a sequence of statements. You see the 3 sequence of statements that are executed under the repeat statement. Okay, the repetition can be done in different programming languages. We can do it in OU build, we can do it in Python programming, we can do it in any other programming language. This is repeat fixed number of times. That is repeat 6 times, for example, in our case. Okay. Python does not have a direct equivalent to repeat until, so we are going to use in Python another way of using repeat. Like we keep a box count here. How many box? Box count is less than 6. Enter the price, add the price to the total, increment the box count. Box count initially 0, 0 plus 1, 1. So it will go and check 1 less than 6. It will enter the box price, add the box price to the total, increment the box count. So it will go again. Okay, what is Python? Python is actually a programming language like C, Java, C++, JavaScript, ASP.NET. Python is a programming language. So in considering looping in Python, a while loop repeat a particular condition until the condition is holds. I mean until the condition is true, the loop is repeated. Okay. Once the condition becomes false, the loop will not repeat. Whereas in OYO build, repeat until will work until the condition is false. Once the condition is true, repeat will stop. But in Python, it is opposite. The condition becomes true, the repeat will stop. The repeat will continue. Once the condition becomes false, the repeat will stop, which is opposite to the OYO build. Okay. Here is an algorithm for a program to count down numbers from 1 to 10. Now here is set I to 100, repeat until I is less than 1 and tell the user value of I, decrease it I by 1, tell the user blast off. Now what change could be made to the condition in order to repeat until with repeat while? Replace repeat until with a repeat while. So we need to just change this sign. Well, I is greater than or equal to 1. Repeat while I is greater than or equal to 1. Instead of using until, if you use while. Okay. So, or repeat while I is greater than 0. So that's about the repeat statements. So in any programming, in any algorithm, we use a repeat statement. In any algorithm, we use a repeat statement. So that repeat statement is to repeat a set of instructions based on the requirement. However, what are the statements you want to repeat? How many times you want to repeat? If there any condition or is there any fixed number of times that you have to see from the algorithm. Back to our cola example of algorithm example of cola merchant. We have the selection statement. The selection statement is if total price is greater than 5,000, calculate the loyalty point, round the loyalty point, tell the user loyalty point. Else tell the user no loyalty points earned. So this is the if then else selection instruction where one instruction is selected based on the condition. If the condition is true, the first block, the if block, we call this as an if block, is executed, and if the condition is false, the else block is executed. This is in case the condition is false, and this is in case the condition is true. The condition is true, the if block is executed, and if the condition is false, the else block is executed. So this selection starts by considering the condition total price is greater than 5,000 euro. If the condition in the if part is true, then it will calculate the loyalty points, then round the loyalty points, and then inform the user or tell the user that you have earned the loyalty points. Okay. Now, if the condition is false, if the total price is not greater than 5,000, it is less than 5,000, then it will go to the else part and say that no loyalty points earned. So if you put this in OU build, so this is how it will be. If total price is greater than 5,000, loyalty point is to 0.05 multiplied by total price, that is 5% of the total price, and you inform the user that you have earned these loyalty points. Okay, else if not, else you say no loyalty point is earned. This is in OU build. If you write this in any other programming language, for example, in Python programming language, this will be like this. If total price greater than 5,000, loyalty points is round of 0.05 into total price, and say you have learned the loyalty points. Else, print no loyalty points is earned. This is what the selections, right? Nested selection, for example, suppose I always provide for my children the same meal on the same day each week. So how I write this algorithm? For example, input the day, how to write an algorithm for this. First we ask the day. If the day is Monday, then set the meal to meat loaf. If the day is Tuesday, then shepherd pie. If the day is Wednesday, omelette. Thursday, chili. Friday, fish chips. Okay, and then output the meal. Now in this algorithm, there is a selection. There is a selection, sequential selection, one after the other. It will check the first condition. Day is Monday. If it is Monday, set the meat loop and output the meat loop. If it is Tuesday, it will set the meal as shepherd pie, output the shepherd pie. If it is Friday, it will set the meal as fish and chips, output the meal. Okay. So this can be written something like this in OU build or also in Python. Here M means Monday, T means Tuesday, V Wednesday, W, TH Thursday, F Friday. Okay. The previous code works fine, okay, but not very elegant. Where this code, every instruction or every condition is checked. First, it will check for M, Monday. If it is Monday, it will set this loop, and then it will check for T. Even it is Monday, it is set for loop. Then go for second condition false, third condition false, fourth condition false, fifth condition false, and then it will print the mean. So you see that even the first condition is true, and we set the mean to meet loop. But still the second condition, the third condition, it is go on checking. To take out this, we can put it like in a nested selection. In a nested selection by using if else if. By using if else if. So what I will do in if else if is that first we check if the day is Monday, set the mean. Else, if not Monday, it will go to check Tuesday. If not Tuesday, then it will go to check the Wednesday and so on. If the day is Monday, then it will not go to check Tuesday now. It will directly come out because it is nested if inside another if. So it is like if, the outer if, then the inner if, then the inner if, then the inner if. If this if is false, then it will go to the inner if. If this if is true, then it will directly come out. Okay, this is called nested if. We also have the switch instruction that can be used. We don't have switch instruction in OU build, but other programming languages, if you study Java, if you study Python, you will see the switch instruction. This switch instruction basically has the cases. Whatever we want to switch, we will put it here as an input. Switch of day. We want to switch the day, which day it is. We have the cases. Case, 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 case. Under every case, there is some statements. Under every case, there is some statement. When we switch the day, we enter the day. For example, it will ask you enter the day. We say M. It is Monday. So it will go to look for the cases case M. So case M is matched. It will print meatloaf today. Break the switch and come out of the switch. Break here it means break the switch and come out of the switch. Now what if, for example, day, if I enter day as W. So for what happens, it comes into the switch W, check for the case M. M is not equal to W, it will go for the next case T. T is not equal to W, it will go for the next case W. W is equal to W, matching case, it will print omelette today, break the switch and come out. Okay, this is how the switch instruction work. So you can have the switch in different programming languages, but we don't have the switch in OU build. Fine. This is also a selection statement. It is also a selection statement. So these are four different points based on which you can write the algorithm. Those are the input outputs, sequential statements, select repetition, and selection statements. Okay, using those in different way, we can write a good algorithm. Right? Now, what is a good algorithm? Which algorithm we consider say okay, it is a good algorithm. Okay, till now what we have seen is how good the algorithm is written so that we can convert that algorithm into program. How clear the algorithm is written so that we can convert that algorithm into program. But we will look into some other factors that describe an algorithm as a good algorithm or not good algorithm. One possibility is measure the goodness in terms of which algorithm is easiest to understand. If an algorithm is clear, it can be easily translated into computer programs. The second idea to think about how much effort an algorithm will take to carry out each algorithm or to carry out the execution. When we design an algorithm, we expect to use it many times. So we want an algorithm to be efficient and require more effort and not require more effort and time than necessary. It means that we want to design an algorithm that will not take much time, much memory to run or to give us the result. For example, we want to write an algorithm to make a cup of coffee, and we want to implement this in a machine. When we write this algorithm, we will test. We want to know how much time it will take to make a cup of coffee. Will it take 2 minutes? Will it take 5 minutes? Will it take 10 minutes? Okay, and how much memory or how much resources this algorithm will take when we implement this in a system. For example, let's say one algorithm will take 1 megabyte, another algorithm will take 10 megabytes. Okay, now which algorithm is efficient? For example, which algorithm is good? For example, let's say that I have algorithm A1 and an algorithm B1. Algorithm A1 and B1 both is to make a cup of coffee. Algorithm A1 takes 2 minutes to make a cup of coffee and it takes, for example, 2 megabytes of memory in the system. And B1 takes 5 minutes to make a cup of coffee and it takes again 10 megabytes of memory to make a cup of coffee. Now, what do you think? Which algorithm is better? B1 or A1? Yes, students online. Which algorithm is better or good algorithm? B1 or A1? Algorithm A1. How about the other students? Is it algorithm A1 or B1? Algorithm A1 to be considered as good algorithm because it takes less efforts. It takes less efforts Fine. That's why we consider algorithm A1 as good algorithm. As good algorithm. Okay. Now I'll have another choice here. I have an algorithm A1 with which takes 2 minutes and it takes 2 megabytes. And I have another algorithm B1 that also takes 2 minutes and but takes 5 megabits. Sorry, it takes 2 megabytes. A1 takes 5 megabytes. 2 minutes, 5 megabytes. This is 2 minutes, 2 megabytes. Sorry, 3 minutes, 2 megabytes. Okay, that's okay. That's okay. Let's put it here. Let's say that I have this another algorithm A1 which takes 3 minutes, okay, and 2 megabytes. And I have B1 that takes 2 minutes and 5 megabytes of memory. Now, which one you consider as a good algorithm? B1 or A1? B1. Why you consider B1 as A1? No, those who said B1, why you consider B1 as good algorithm? Yes. Those who said B1, why you consider B1 as good algorithm? Yeah. We know that B1, A1 takes more time, less memory. B1 takes less time, more memory. Right? So if you say, for example, let's say B1, it takes more time. It takes 3 minutes. Memory 2 byte. But if you take B1, sorry, it takes B1 2 minutes, 5 megabytes of memory. A1 3 minutes, 2 megabytes of memory. Now here, the time is more important than memory because memory is available and it is cheap, right? Memory is available and it is cheap. And 2 megabytes of memory is nothing. And you can buy it very cheap. And you need to buy only one time. Whereas 3 minutes it takes is 1 minute every time. If you want to make 10 cup of coffee, B1 will take 20 minutes. A1 will take 30 minutes. Right? So time is more important here compared with the memory. Time is more important. So we consider B1 as a better algorithm because it takes very less time compared to A1. Memory is not that much of importance because memory we buy only once and it is cheap. It's not costly. Memory is not costly, it is cheap and we buy it only once. Fine. So one thing to consider in this algorithm is that what is the effort the algorithm will take? What is the time it will take? What is the memory it will take? Those things we are going to consider fine in deciding which is a good algorithm. So the first point is important. Like understandable algorithms are more readable computer programs that are easier to maintain. So understandable algorithms are good algorithms. Okay, but second thing is that the second point is not quite straightforward to answer. It may not be immediately apparent that two algorithms perform the same task in different amount of effort. So a different amount of effort here it means uh, different memory it will take, different time it will take. Okay, we take this example. Suppose 100 gets attends FAT, How many arithmetic operations we require to calculate total cost of cupcakes by algorithm A and algorithm B? We can plot both algorithms on a graph, okay, as given here. Fine. So number of operations it takes, number of gets it has. Fine. For both algorithms, the number of operations increase along with the number of guests. Both algorithms produce a straight line on the graph between the number of operations and number of guests. Algorithm A is inefficient since it takes more operations compared to algorithm B. So algorithm A has more operations. That means it is taking more time, more effort than compared to algorithm B. Algorithm B is taking less effort, less time. So we consider algorithm B is what? Good algorithm. Okay. So that's about the algorithm when we say what's the good algorithm or not good algorithm, or which is the better algorithm, we can say. The next topic here. So you got an how we decide what is the best and what is a good algorithm. Students online, they get what is good algorithm or which is a better algorithm. Is it clear? Students online, is it clear? Okay. The next topic here is swapping. Swapping is nothing but exchanging of two values. For example, let's say that I have two values 20, x has 20, y has 30. Swap or swapping. Swap it means what? Give the value of x to y and y value to x. That means make x 30 and y 20. That is called swapping or exchanging their values. It's called swapping. So swapping of two items is a fundamental activity. It is also used in algorithms where we use sorting, where we sort the data or where we want to sort the data. Swapping it means exchanging of two items. For example, if you have item 1 and item 2 that you want to exchange, let's say it is Bob and Alice, and you want to exchange this, fine. This can be done by this algorithm. For example, swap this set item 2 to item 1, then item 1 to item 2. But it is not possible by this. If you write this algorithm, set item 2 to item 1. So it means you set the item 1, item 2 to item 1. So item 1 is Bob. Set the Bob to item 2. Then you set item 1 to item 2. Item 1 is what? Sorry, item 2 is Bob now. Set that to item 1, Bob. So you say Bob, Bob. There is no swap here, right? By this statement. So what we'll do is we need to bring a temporary variable here to make an exchange. That first we put Bob into temp, then we put Alice into item 1, then we put Bob here by using a temporary variable. Or if you want to say, for example, x and y, you want to swap x and y. X is 20, y is 30. X is 20, y is. What we'll do? We'll take t here, temporary variable. We say t is equal to x. So what is t now? 20, right? Then we say x is equal to y. Now what is x now? 30. Then we say y is equal to t. Now what is y now? 20 from t. Okay. Now after this, you see that it is swapped. After this statement, you see that 30 is in x and 20 is in y. So this using a temporary variable, we can do the swapping. So this is an algorithm for swapping. Okay, you can do this also in the OU build or in the Python. It's a 3-line code. Temp is equal to item 2, item 2 is equal to item 1, item 1 is temp. Very simple. Clear? Is it clear to all? Okay, the next topic here is sorting. Sorting is nothing but arranging the numbers or values in a particular order. In a particular order. For example, arranging the numbers from 1 to 10. Okay, so for example, let's say that I have these numbers 23, 1, 45, 23, comma 1, 2, comma 34, comma 12, comma 5, comma 4, comma 1. Okay, sort this number in ascending order. Ascending order, it means, what is ascending order means? Ascending order, it means from smallest to the largest. So what is ascending order in this one? 1, then we have 2, 1, 2, we have then 4, then 5, then 12, then 23, then 34 in ascending order. 1, 2, 4, 5, 12, 23, 34. That is in ascending order. So sorting is nothing but arranging some values. Even you see in your mobile phone, you will take the contacts, it is sorted in alphabetical order. In the alphabetical order. So either you sort numbers or you sort names or you sort any other value that goes in order. That is called sorting. Sorting algorithms take a list of unsorted data, then turn them into a sorted data. Turn them into a sorted data. For example, sorting can be in ascending sort or it can be in descending sort. So if we take this example, this is ascending sort. Now what is descending? Descending order of the same is 34, then 23, 12, 5, 4, 2, 1. This is descending order. So it can be ascending or descending. Arranging the alphabetical order from A to Z or from Z to A. Arranging the dates. Okay, these are all comes under the sorting. So sorting takes the input as a list of values, a set of values. For example, here is a short list of names: Ahmad, Basil, Marwan, Saif, Ziyad. This is sorted in ascending order. Okay, so a list made up of item of data, each having position in the list, and the first item is in the first position, second item is in the second position. So Ahmed in first position, Basil in second position, Marwan third position, Saif fourth position, Ziad fifth position. So in the list there is a position. Now if you talk about, for example, this list. So position is 1, 2, 3, 4, 5, 6, 7. And what is the length of the list? What is the length of this list? The length is 7. That is the number of elements in the list. Okay. Now, is this list sorted? Here is a question. Is this list is sorted? Students, is this list sorted? No. The answer is no. It is unsorted. What is the length of this list? It is 7. What is the item at position 6? What is the item at position 6 in this list? It is Biblos. Biblos is the, what is the position of Petra in the list? Position 5. Okay. So this is the about the list and the list elements. List elements, the length of the list, position of the list items and all. Okay. So we have different sorting techniques in computer science. We have different sorting techniques. We can sort the elements in different ways by using different techniques. Okay, we have selection sort, we have bubble sort, we have merge sort. Fine. We'll look into selection sort and bubble sort here. Selection sort is this algorithm repeatedly search for the smallest or the lowest item in the list in an unsorted list and move the item to the end of the sorted data. The algorithm repeats until the data is sorted. Selection sort can be implemented by using two separate lists, one sorted list, the other is called unsorted list. Such algorithm is also called not-in-place sorts, but they are not often used in computer programs. There is a more elegant way of sorting by both sorted and sorted portions. The algorithm sorts the item within the original list known as in-place sort. Now let's see how this algorithm works. The selection sort algorithm works. The algorithm works in place selection sort. It can be written as repeat until only one item is unsorted remains. Find the lowest item in the unsorted data. Swap the lowest item with the first item in the unsorted data and you repeat the same. It means first you search for the lowest element and you replace this lowest element in the first position. Then you find again second lowest element. Replace this second lowest in the second position in the list. Third lowest element. And you repeat for all. For example, let's say this is the list. First thing, scan the items from 1 to 5. This is 1, 2, 3, 4, 5. Search the item from 1 to 5 and find the smallest element. Smallest is what? 20. Swap this 20 with 35. So 20 comes in the first position, 30 goes in the position of 20. That is in the last position. So this is a sorted list now. 20 is in its position. Remaining list is from 2 to 5. From 2 to 5. Find the lowest element or the smallest element. Here it is 30 is the smallest element. Replace this with the first element in the unsorted list. That is swap it. So 30 comes here and 64 goes in 30 position. So now in this step, this is the sorted list and this is the unsorted list. Now again scan the smallest element from 3 to 5. 35 is the smallest. Swap this with the first in the unsorted list. So 35 comes here, 65 go in place of 35. Now this is the sorted list and this is the unsorted list. Now find the smallest element 16. It is in its position. So it remains as it is. Only one item is remaining. So you stop here and you see the list is sorted. The list is sorted. This is called selection sort. Is it clear to you all? Selection sort. Anyone has any question on selection sort? Okay, that's about the selection sort. Another type of sorting is called bubble sort. Bubble sort. Like selection sort, bubble sort is also based on comparing and swapping. Okay, but the bubble sort will swap the elements as it go on finding the elements. It will not swap the first element. It will not swap the first element. It goes on as it goes on comparing the elements. It go on swapping the elements. It is like this. Start at the beginning of the list. Repeat for every pair of adjacent items. If the item is in wrong order, swap them. Okay. For example, if you see this list of items 77, 42, 35, 12, 1015. Okay, you start from here. Compare the first two elements, that is adjacent elements. They are in order? No. 77 is greater than 42. Swap them. They are not in order? Swap them. Okay. Then you compare 77 with 35. They are not in order? Swap them. Then you compare 77 with 12. They are not in order? Swap them. Okay. Then you compare 77 with 101. They are in order. 77 is less than 101. So you keep it as it is. Move to, no need to swap. Move to 101 with 5. It is not in order. 5 is less than 101 or 101 is greater than 5. Swap them. And you see that at this point, you see 101 comes in its position. Okay. Now you repeat the same process for the remaining list from 1 to 5. 42 is now compared with 35. They are not in order, swap them. 35 comes here, 42 goes there. 42 compare with 12, not in order, 12 comes here, 42 goes there. 42 with 77 in order. 77 with 5, not in order, 5 comes here, 77 goes there. So you see that this is the list here. Now you do the same thing again. We have 35 here, 35 with 12, not in order, 12 comes, 35 goes there, 35 with 42, in order, we keep it as it is, 42 with 5, not in order, 5 comes here, 42 goes there. Okay, now remaining is this list. 12 with 35, in order, 35 with 5, not in order, 5 comes here, 35 goes there, 12 is here. Now in the last, 5 comes in the first, 12, 35, then 42, then 77, then 101. Okay, so this is the bubble sort by bubbling the elements. Okay, once you're remaining only one element, you stop there. You're gonna stop there. This is called bubble sort. So two sorting techniques we have seen. One is selection sort, the other is called bubble sort. Okay. So you may be asked in the exam about these sorting techniques like sort the elements by using bubble sort or by using selection sort. You need to show the steps. Okay, how the sorting is done. There is another called merge sort. We don't have how the merge sort works, but this is another technique where the sorting, the lists are divided into a small list and the sorting is done during combining the elements after division. Fine, but this is considered as more efficient sorting technique, merge sort. Okay. So this is all. We have two sorting techniques, bubble sort and the selection sort. As a summary to this part, having completed this part, we should be able to describe the what is an algorithm, what is a good algorithm, fine. Fundamental blocks of algorithm, that is the input, output, repetition, selection, sequential, fine. How we write from an algorithm into a program in the OU build or in Python programming language or in any other programming language. Then we talk about sorting, sorting algorithms. What is sorting? Then we talk about sorting algorithms like bubble sort and selection sort. Then we discuss about examples by taking the bubble sort and the selection sort. Fine. So this is all what we have for you in this part number 6. Okay, now just have a look before we move into what is covered for the midterm exam. We are covered with the midterm exam.